Hello viewers, my name is Kuldeep Singh. Welcome to my YouTube channel Technical Skills. Guys, if you are new to this channel, please subscribe this channel and please do hit the bell icon for latest updates. Hello viewers, if any one of you is interested in taking online or offline training, you can contact me on the number given on screen. You can call me or you can send me a WhatsApp message. Also, you can check my number in description of video. Thank you very much. Hello viewers, welcome again to new session of PLC tutorials. In this session I will cover timers. So let's start with the timers. So you can see on screen, first is the types of timers. First of all, I would like to tell you that here I am discussing about only Allen Bradley PLC. So these are the type of timers that you will generally get in Allen Bradley PLC. So let's start with the types of timers. Types of timers, there are three types of timers basically in Allen Bradley PLC. First is T-on timer, timer on delay. Second is T-off timer, timer off delay. And third is RTO, retentive timer on delay. First type of timer, timer on delay, as you can get from the name, that it will give delay in on time of an output. Okay. Second is off delay, and it will give delay in off time of an output. And last, retentive timer on delay. Retentive timer, I will discuss it later, so I don't want to create any more confusion. That's why let's concentrate on first on T on and T off, then we will get to RTO, retentive timer on delay. Okay. So first of all, T on, timer on delay. Timer on delay is generally used, you can see the description on your screen. Apart from this, I will just like to explain you in a layman language that T on timer, what is a T on timer? That T on timer gives delay in on time. In earlier, you have seen my video tutorials that what we were doing, that we used to switch on the input and we get the output. But now we want to get the output after a particular time. We want to give delay in, suppose want to give delay in starting a motor, in starting a pump. Okay. So pump and motor is the output. So we want to give delay. Suppose we want to give delay of 30 seconds or a minute or an hour. So whatever the delay we want to give, we can use a timer. We will give input to the timer and timer will give the delay to the output. So this is how T-on timer works. As on what is written in the slide, T-on timer is used in PLC programming where we have to switch on an output after a particular time delay. T-on timer gives delay as per specific in T-on timer instruction. Whatever the preset you have given, whatever the time you delay you will given in this instruction, that much time this instruction will follow and it will give that much a delay. Okay. So this is the this is for all for T-on timer. And next is T-off timer. T-off timer is generally used to give delay in off time. Generally, like if I enter room, I switch on the light will get on. If I want to switch off the light and I want to get out of the room and I want that much delay, that at that time, that particular time, for that particular time, the output, that light should remain on. So that is the, I'm giving delay in off time. When I switch off the switch, then the light will get off after some time. So that is the off delay. That is where we are using the off delay timer. It's just an example. T-off timer off delay is used in PLC programming where we have to switch off an output after a particular time. We don't have to switch off the output immediately. We have to switch off the output after a particular time. Then we will use T-off timer. T-off timer gives delay as per specified in T-off timer instruction. Okay, this is the same for as of T-on and as of T-on. Whatever the time duration we will set in this instruction, that much time this instruction will follow. Next is RTO, that is a retentive timer on delay. It is generally a type of T-on timer only. Retentive timer on delay is used in PLC programming where we have to keep a time track of particular event or output. Like if let's give you example. Suppose I want to give a track, I want to track a time for a particular pump that is running for 10 minutes after every it is getting off also, it is getting on, it is getting on for 10 minutes, then it gets off for suppose half an hour, or randomly it gets on after 45 minutes. Okay, so whatever the time, the running time, I want to calculate that running time, how much running time is that of that oil pump or a water pump in whole day, in 24 hours, that I can calculate from RTU. The RTU generally whatever the time we give, it calculates the time and holds that time, whatever it records the time. Retentive means it holds the time. Okay, whatever time we give to this RTU, that much time, it will just count the time. Okay, suppose oil pump is running for 10 minutes, then it will count 10 minutes, then it will hold and it will record the 10 minutes in this accum, and again when it again gets on, it will again start from that much time, from 10 minutes, it will count onwards from 10 minutes. Okay, so this is RTU. And basically, if you learn about how we are using it, we can learn in that practical, whatever the questions we will follow. I will give you the example where RTU we are using an RTU. So from there we can learn more about the RTU. For this time, it's this much only. So next is addressing of timer. How to do the addressing of timer? So to addressing of timer, this is the what you can say syntax or a formula. This is file type, file name, colon, timer number. File type is T, file name is 4, colon, 0. Timer number we start from 0. T4 1, T4 2, and so on. Then how much timer we can use depends upon the memory of PLC and type of PLC we are using. Okay, so it is different for all PLC. So we cannot specify a number where from up to which number we are using the timer. Okay, so this is what the timer address we are using. Next are the specification in these instructions that we can see in T on timer or T off timer or RTU timer. All the basic details are the same. Like it is written T timer. It is written timer T40. In front of this timer, we have to give the address of timer T40. Next T41, T42. Depends upon how much timer you are using. Next is time base. Time base, there are, you can see I have written this time base interval. It is 1 second, 0.01 second, and 0.001 second. So these are the three type of time base you will get in this. When you click on this, I will show you that in an example. When you click on this time base, you will get these three options: 1 seconds, 0.01 seconds, and 0.001 seconds. Okay, this is time base interval. Okay, and next is preset. Preset is set point of a timer. Set point of timer up to what time, what number the timer has to count or calculate. Okay, set time of timer will be from 0 to 32676, 32767, because the timer is generally uses a space of a word. That's why it goes up to 32767. Last is accum, or we can say accumulator. It will show the time counted. With the time counted, you can see here in accumulator. Next is, yes, this is the important thing. Total time delay doesn't means that is the preset value. Okay, preset value is not the total time delay. Total time delay depends upon the preset and time base both. So preset into time base is total time delay. So if preset is 10, let's give you with show you the example. Okay, just a minute. Let's show you the example. Let's total time delay. Okay, preset set into time base. Okay, is equal to total time delay. Okay, let's, if a preset is, suppose let preset is equal to 10. Okay, if preset is 10, then when I will follow this formula. Okay, if I follow this formula, then preset is 10 into time base. Time base, suppose 1 second. Okay, 1 second, then total time delay will be equal to 10 second. Okay, but if preset is 10 and time base is 0.01 second. Okay, then total time delay will be equal to 0.1 second. Okay, and if preset is 10 and time base is 0.001 second, then time delay will be 0.01 second. Okay, so time delay basically depends upon both preset and time base. So we have to select the time base and preset accordingly as per we require the total time delay. Okay, so this is the about the time delay. Next is timers. There is enable bit and done bit. You can see here EN is enable bit, DN is done bit, and TT is timer bit. There are 3 bits we generally use for timers. So let's start with the addressing also of TT bit and enable bit, timer bit. Addressing of TT bit. TT bit generally stands for timer timing bit. It is timer timing bit. Okay, timer timing bit is TT bit, and next is done bit. DN stands for done bit, and EN stands for enable bit. Enable bit. So this is the timer timing bit. This is TT. TT stands for timer timing bit. Okay, this is TT. TT stands for timer timing bit. DN stands for done bit, and EN stands for enable bit. Okay, so, and we have to write the address also. So for giving address of TT bit, what you used to see, addressing of TT bit is T4:0/TT. T4:0 means whatever the timer number you're using. It may be T4:0, it may be T4:1 or T4:2, whatever the timer number is, /TT. And then other is DN bit. DN bit is T4:0/DN. Okay, and next is enable bit, and that is T4:0/EN. And what is this enable bit, what is TT bit, and what is done bit? Let's explain first this. Okay, so TT bit is generally, enable bit is generally that the timer gets enabled, and it is just an indication that timer is getting a supply and timer is running. That's just the enable bit. Okay, and done bit is that timer has completed the whole time. He has counted the time that accum is equal to preset. Accum has calculated up to preset value. That is the done bit. And timer timing bit is up to when the timer is timing, when timer is counting, that time this bit gets on. So that is timer timing bit. Okay, so let's go for an example. Let's get an example, then we will learn more about the timer. Okay, let's start with this example. So suppose I have to use a timer. So this is input, and here I will go to timer counter. This is the where I will get the T on timer. This is T off, and this is RTU. Let's go for T on timer. Okay, so this is input, this is timer, and I would like to tell you that if I place output like this is wrong. Okay, I cannot place output after the timer. Why? Because timer is self output, so we cannot put 2 outputs in series. That's why we cannot use this output here. Okay, what we'll do, we'll use N over here and output over here. This is input I1:0 this input, and here I have to address a timer T4:0. This is timer. Then this is you can see the 3 time base. So let's start with the 1.0, and next is preset. You can put any preset, 10, 0, 5, any preset, not 0. 10, 5, 20, whatever you like to put. Okay, next is here, let's start with the done bit first, T4:0/dn. okay, and here is like can give an output. Okay, so compile it, let's download it. Okay, so when I will switch on this input, this enable bit will get on. It will indicate that timer is getting supply, timer has got the supply and timer is working. Okay, now when this timer gets the supply, this timer will start counting in accumulator. You can see the counting in accumulator, and when this accum will equal to preset, when the time counted will be over, then this done bit will get on, and this done bit I can use it here, done bit. So this input is just a done bit, what you can see in this timer. So this done bit will get on and this output will get on. Okay, let's see. When we'll start on input, see, enable bit is on. Now the timer is counting 3, 4, 5. When this accum will be equal to preset, then this done bit will get on and this output will get on. Okay, when I will switch off this input, you can see the timer will get reset. Okay, the output is off. When you will again switch on this input, see, enable gate is on, the done bits timer is counting, and after 10 seconds this done bit will get on and this output will get on. Okay, so when we'll switch off this, so this is the done bit. Okay, so now the next is TT bit, timer timing bit. So I will just replace this done with TT. Okay, so you can understand TT. I am just telling about this T on timer first. Okay, so now let's check. First, force on, enable bit is on. You can see accum is on and TT is on. TT is timer timing bit. Whenever the timer is timing, up to that time this output will on. When accum is equal to preset, this output will get off. You can see. Okay, let's check once more. When I'll switch on this input, you can see enable is on, TT is also on. TT will remain on till accum is less than preset. When accum is equal to preset, the TT will get off. Enable will remain on till this input is on. When I'll switch off this input, then this enable will get off. Okay, so this is how TT works. Okay, so if we will see both TT and done. Okay, let's take two outputs, one with the TT, one with the done bit. Okay, T4:0/dn. Okay, and now another output O0. Okay, now compile it and now download it. When we'll start with this, see, enable is on. First, the TT is on till accum is less than preset, TT will remain on. When accum is equal to preset, the done bit will get on. So this is how this timer, T on timer works. Okay, so we can write down here, over here, when TT gets on, it gets on when accum is less than preset. Okay, and when this done, mostly these two bits you will use in timers, TT bit and done bit, and this gets on, done bit it gets on when accum is equal to preset. So I am talking about the T on timer. So this is the basic funda of timer. So I am getting this class over. So this is how timers work. So this is it for today's class. Thank you very much. Keep learning, keep practicing. Thank you very much. Hello viewers, If any one of you is interested in taking online or offline training, you can contact me on the number given on screen. You can call me or you can send me a WhatsApp message. Also, you can check my number in description of video. Thank you very much. Thank you very much for watching this video. Please subscribe this channel. Also hit the bell icon for latest updates. Please give this video thumbs up and do share it with your friends. Also please comment below how do you like this video. If you have any questions, please comment below. I will definitely answer your questions. Thank you very much